In this lesson, we're going to take our two-dimensional shapes and start rotating them to create three-dimensional objects. Remembering from the last lesson, these are four of our basic two-dimensional shapes, formulas that we need to know and know how to use. We have the rectangle, which is area equals base times height. The square falls into that category. We have the triangle, so where area is equal to 1/2 base times height. Our parallelogram works like the rectangle, area equals base times height. And then the trapezoid is the one that had the two bases. So we're looking for the parallel bases on the trapezoid. And we add those two together. So let's do a couple of problems to review what we were doing previously. So A, we can see, is the shape of a triangle. So we're going to use this area equals base times height divided by 2 formula. First we write our formula. A equals 1/2 base times height. We substitute A equals 1/2. Here we need to figure out what our base is. So the base here we can count to be 1, 2, 3, 4, 5. So we have a base of 5. And remember, we need a vertical height. So we're going to go straight up. And then count that height. So we have 1, 2, 3, 4, 5, 6. So a height of 6. We can plug that into our calculator and we get an area of 15 units squared. 15 units squared. Shape B is also a triangle, just a different shape, different base, different height. So we're going to use the same formula, area equals base times height. A equals 1/2. Let's figure out what our base is. Base down here, we can count that off. 1, 2, 3, 4, 5. Still have a base of 5. Again, make sure you are doing vertical height. I'm going to go straight up. Count that. 1, 2, 3, 4, 5, 6. We have a height of 6 again. And since our base and our height is the same, we're going to end up with the same area. So we got two different shaped triangles that give us the same area of 15 units squared. Now C is a trapezoid. We can see our formula here. We have A is equal to, this divided by 2 is the same as multiplying by 1/2. So we've been writing it as A equals 1/2 B1 plus B2 times the height. We're going to plug in A equals 1/2. We've got two bases. We're looking for the parallel sides. You can count those off. The short one is going to be 2 units long. We're going to add to that the other base, 1, 2, 3, 4, 5, 6. 6 units long. And then we want a perpendicular height. It has to be perpendicular. 1, 2, 3, 4, 5, 6. We also have a height of 6. And we can plug that into our calculator. And you're going to get 24 units squared. Last shape we have is a parallelogram. The parallelogram area works just like the rectangle. So A is equal to base times height. Our A is equal to our B value. Make sure when you take this base, you're not extending past that side. We only want the segment that is contained by the parallelogram itself. 1, 2, 3, 4. We have a base of 4. And again, just like on the other shapes, we want our vertical height. 1, 2, 3, 4, 5. This one has a height of 5 units. We plug that into our calculator and we get area equals 20 units squared. So that's just calculating area. Now we can start looking at how two-dimensional shapes make up our three-dimensional objects. And there are certain three-dimensional objects that we need to be able to identify and work with. The first one we have is a cube. And we know that a cube is made up of 6 squares. If it is a cube, we're going to have 6 squares. Now if it's a rectangular prism, instead of just squares, we now have 6 rectangles. So we can either have 6 squares if it's a cube, or 6 rectangles if it's just going to be called a rectangular prism. The next object we have here, this one is going to be a pyramid. They told us it was a rectangular pyramid. That is our base. The rectangle is the base. This one, we know that we have one rectangle on our base, and then we've got the 4 sides, which are made up of triangles. So then 4 triangles. One rectangle and 4 triangles. The third one we have is called a cone. The base shape is going to be a circle. And then the sides there, you can see, are created by a triangle that is wrapped around that circle. So you've got one big triangle wrapping around that circle. Shape 4 here, what we have is a sphere. And on the sphere, what we have is one circle that is being rotated in every direction. So you can see around the center here, we have this circle, and we're going to rotate it. And as we go in different directions, that one circle gets rotated in 3 dimensions, creating that sphere. Next object we have is a cylinder. You can see the circle at the bottom here, and the top and the bottom are going to be the same, so we actually end up with 2 circles on a cylinder, and then the side is just a single rectangle wrapped around those circles. On the cone, we had a single triangle wrapped around the circle. For the cylinder, we have a single rectangle wrapped around that cylinder. Number 6, we have another rectangular prism. Oftentimes, the bases here will be different from what we call the faces. We've got 2 bases and then 4 faces. It gives me a total of 6 rectangles. To sum up our notes here, we said that we had a rectangular prism, that has 6 rectangles. We have a rectangular pyramid that has 1 rectangle and 4 triangles. A cylinder with 2 circles and 1 rectangle. And then our cone is going to have 1 circle, 1 triangle. So let's fill in some notes. Here we have a cube. A cube is contained by 6 squares. All 6 sides are going to be congruent to each other, so we have 6 squares. Next, we have a rectangular prism. So instead of 6 squares, we now have 6 rectangles. Bottom here, I have a rectangular pyramid. The rectangular pyramid is contained by 1 rectangle, that could be a square, and 4 triangles. The 4 sides there will be 4 triangles. Our next shape, we have a cylinder. This is something we have to be able to do. You need to be able to identify what the object is. Contained by 1, so the face is a rectangle, and the 2 bases will be circles. Bottom left here, we have a cone contained by 1 triangle and 1 circle. The base is a circle, the face is a triangle. Then here we have a sphere. Your definition of a sphere here is every point is equidistant from its center. That's going to be the definition of a sphere.